Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is part 6 of this series of streams in which I'm working on this open source project of mine called Caxa. And joining me today, I have a special guest, David, for the first time on the show. Hi, David. How are you doing?
Hello. Very well. How are you?
Awesome. So, introduce yourself to the audience.
Yes, I'm David Adler. I'm a CTO at a small startup in London called Onin. I work mostly with React, TypeScript, JavaScript, backend, frontend, React Native apps. Yeah, and that's me.
Yeah, and how do you deploy these apps?
Well, we're using serverless actually.
Cool.
Um, yeah,
So
so AWS serverless.
one of the inspirations for Caxa was this package called PKG, stands for package,
Mm,
which was created by Versal, the company that pretty much pushed the idea of serverless into mainstream, I think. I have
yeah.
never heard of the Jamstack before they started talking about it. And I
Mm,
think that the way they implemented the serverless functions at some point was using something like PKG, which is similar to Cacha. I don't think they're using it anymore because it seems like the development isn't very active. It wasn't too active this past few months. I think they're starting to pick it up again. So maybe they are using it again on their serverless infrastructure. But it seems like you are.
well, I saw it.
It's.
I actually
Go ahead.
Oh, sorry. Well, I checked just before this stream actually because I was curious about PKG, and it's like the first thing you read is there's a disclaimer which says PKG was created for use within containers and is not intended for serverless environments.
Well, you as a developer writing a React app should not use PKG or Cacha if you're deploying to a serverless situation. But I think that under the hood, they were using, or maybe still using, or maybe they're going to switch back to using it. I don't know the
Mm,
story there. I don't know how they implement their infrastructure, but
mm.
I don't think that they had anything like Docker or other containerization solution. I think that they were using something that would package your application into a binary. It's just a guess, though.
Got
I
it.
don't know how they do stuff.
Makes sense. I mean, why else would they create it, right?
Yeah. So for you uh, in this servers, it seems like, well, it's not actually a server, it's serverless, but in these back-end functions, it seems like Cacha would not be useful for you, right?
No, not at all.
But do you,
In fact, like it's a bit of a black box, our deployment right now. Sort of just, does auto scaling and we don't really worry about it. And we just sort of build the product and serverless takes care of everything for us.
but do you know a little
Um,
bit of what Cacha is and how it works?
yes. I mean, I don't know huge amounts about how it works. As I wrote to you in the email, you might have gathered, there are some gaps in my understanding of how native modules work in Node. Um, but I'm aware that it's a self-extracting binary executable. So when you execute it, it will self decompress the archive within itself, and then that comes with Node bundled in it, and then we'll execute that.
That's exactly right. So, in a nutshell, what you and the audience needs to know for our session today is that Cacha packages your Node.js application into a single binary. Your Node.js may be an application that is a web server, it may be a command line tool, it may be something else entirely. A script that you want to package and let people run by double clicking it. So that's what Cacha does. And the way it works is it is a self-extracting binary. So it is a executable that when you run it, it extracts a bunch of files, which is your Node.js project, into a temporary location. And it includes not only your project, but also the Node executable itself. So people who want to run your binary don't need to install Node.js separately. It will be in the binary. And the way this self-extracting executable works is there is an executable that we call a stub, and this executable loads itself as a file because an executable is just a file. So it loads itself as a
Hmm.
file And it looks at itself as a data structure. So there is this stub that we compile. It's written in Go. And there is a separator so that we know when the binary ends and your project starts. And then there is a tarball, which is just your Node.js project and a Node executable all bundled into a tarball and just dumped at the end of the stub. And then there is a footer with some JSON saying, after decompressing the thing into a temporary directory, what command should I run? Which typically is run Node.js, the version that was packaged along with the project. Run Node.js, this is your entry point, go do your thing. So that's the principle behind how caxa works. And you may be wondering, why do you do that? Well, one of the reasons is precisely native modules. So those are modules written in C and C++, so you can think of SQLite, Sharp, and some stuff to deal with serial ports, that sort of thing that depends on, well, native extensions, things written in C and C++. Well, the thing is, as it stands, Node.js, the executable, insists on loading native extensions from the file system. They need to be a .node file that you find somewhere in the file system. So any project that tries to package a Node.js application into a binary needs to figure out a solution. Some projects try to patch the Node.js executable to work around the way it loads native modules and to change the way it behaves in many ways. Some projects try to extract just the native modules somewhere else, like a temporary directory, but caxa takes this idea to an extreme. Caxa puts all your project, JavaScript, native modules, maybe CSS, images, icons, whatever, in your entire project. It puts that into the tarball and extracts the whole thing into the temporary directory. So it's a naive approach, but the upside is that we don't need to patch Node.js, and it works with any native extension and any operating system and any version of Node, because from caxa's perspective, it may not even be a Node.js project for all it cares. It could be whatever. It could be a text file, and then your entry point could be not run Node with this file, but instead maybe cat a text file. And then your binary is something that you double click and it runs and it cats a file into the standard output. So it could be that. What we did last week was to...
Could I ask a question very quickly?
Go ahead.
So say it's catting a text file. Cat doesn't exist on Windows, let's say. So like you would have to have your program would have to be able to run on any system, right? And that one wouldn't. Yeah,
so the problem of multi-platform is exactly what we are working on this week. So if you were packaging for macOS and Linux, you may include a cat, or if you're packaging for Windows, you would do the equivalent of cat, which I happen to not know what it is, but you would do the equivalent of that.
Dog or whatever.
Yeah, and the issue that we are dealing with here is precisely the problem of multiple platforms. Specifically, I developed this originally for macOS, Linux, and Windows, but people started requesting support for Linux with the ARM architecture because they wanted to run the thing on Raspberry Pis. And also, since we were doing that, I decided to just bite the bullet and support more platforms. For instance, since I started developing caxa, Node.js 16 came out, which has native support for Macs with the M1 processor. So we are now in caxa also supporting, or about to support, ARM architecture in macOS as well. And what we did last week was one half of this story. This week we are going to do the other half. So the two halves of the story are: we need to compile the stub, which is written in Go, to all these different platforms. The second half of the story is, in JavaScript, we need to pick up the right executable, the right stub, and run with it. Now, I said that the stub is written in Go. The reason for that is because I needed some binary to bootstrap the process. I could not write this in JavaScript because then how would I compile a binary to begin with? So to bootstrap the process, I'm using Go. I could have used any other language that would produce a binary. So I considered C and considered Rust, decided on Go. So last week we did this whole setup to compile the Go program. It's a simple Go program. It is just 200 lines, 250 lines of Go. And most of this was copy and paste from somewhere else. I don't know much about Go. But what we did last week was to just come up with a GitHub Actions infrastructure that would compile that Go program into a bunch of executables. So we have here a file that is almost as long as the Go program itself, but what it's doing is relatively simple. So we can go to the project on GitHub, and I can show what this configuration does and how it plays into the rest of this story. So I need to go to this person's branch or fork of caxa. So let's go to maxb2. Oh, now that we merged, I don't think I need to go there, but in any case, I will. So we can look at a successful run of this workflow. So what it does here is it compiles the stub for the different platforms using Docker containers. And I know that Go is able to cross-compile. In fact, before we merged this pull request last week, we were using cross-compilation. So I was using, I think, Ubuntu to compile to all the different platforms, Linux and Windows and Mac. But we learned that there were some weird cases in the cross-compilation and weird bugs. And ultimately, we would need some sort of emulation to be able to test the stubs and to test the project in all the different platforms. So we decided to also compile without the cross compiler, just literally compile on all the different platforms. So to compile for x64 or Intel, that was easy because GitHub Actions has support for macOS, Linux, and Windows natively. So we would just say go to all these different platforms and run Go and compile this and generate a stub. And that Go program that we were looking at before, this program, becomes just a binary that you can come and download here. This is a zip of all the versions for all the platforms. So that's the story for the compilation of x64. For Linux ARM, as I said, we are using Docker. So we spin up a Docker container which has a Go compiler in there, and that is emulating ARM. In fact, I think it's emulating a Raspberry Pi specifically. And then we run the Docker compiler in, we run the Go compiler in the Docker container, which is beneficial in some edge cases. And then, unfortunately, for macOS ARM, so for the new M1 processors, as far as we can tell, there is no emulation, no native support in GitHub Actions, no Docker container that you can use for that. So for this case specifically, Macs with M1 processors, we are using cross-compilation. So that builds all the stubs. Then we run the tests for caxa using the stubs we just compiled. We also do a checksum of all the stubs because and that's another thing we wanted to do. We wanted to build some trust into the process, because previously the way this was working is I had the Go program, I would cross compile to all the different platforms, and I would put the binaries into the Git repository and ship along with the rest of the NPM package. Which is okay, I compiled everything on my machine, and as long as you trust me, you trust the binary, so that's fine. But people were concerned with that, so we are now doing a checksum that you can publicly see on the log, and then you can check that the stub you have is the same one that was built here, and you can see all the logs for the build. So as long as you trust Microsoft, you trust the binaries.
Makes sense. Makes sense. Cool.
And then if you are on a tag, which is not the case of this run, but if you're on a tag, then we will also create a GitHub release that contains all the stubs for all the platforms. And then we publish the npm package that is the JavaScript portion of caxa. So this whole story, this whole GitHub Actions that we did last week was so that we could produce binaries that are the stubs. And now we have them. You can come to the GitHub releases for this, and on test 52, and I asked Matt, who was helping me along with this compilation story. So Matt joined me last week, and he said that yes, there were 52 tests. This is not a random number.
Wow.
But now for any tag, we can come here to the GitHub Actions, and we see all the stubs compiled for all the different platforms. And what's cool about this is that people who want to use caxa from a developer's perspective, so they want to use caxa to package a Node.js application, they don't have to have a Go compiler setup. They can just come here to the stubs and get a compiled version that hopefully they trust because there are some checksums and the whole thing was built using GitHub Actions. Okay, so that's one half. That's what we did last week. The other half is now when installing the package, when you go and say npm install caxa, you are no longer getting the stubs. You used to, but now you're not getting the stubs anymore. And you need to download the right stub. Also, we made some other changes as we were doing this, so we do need to adapt the project here and there, but it's minor stuff. The main thing is we need to get the right stub and download it and put it somewhere where the rest of the JavaScript project will find it. So we need to detect what platform we are on, and we need to download a file from GitHub, and we need to put it somewhere where the rest of the project will find it. That's
interesting.
That's our job for this stream.
Interesting. I'm just wondering. No. Okay. Cool. Sounds good. Just before we continue on this, is it all right? I'm going to grab a glass of water. I'll be back very shortly.
Yeah.
All right. Perfect. See you in a second.
Sure. Okay. So while he's gone, what I'm going to do is something that maybe he has an answer for, but I don't, which is how do you download a file in Node.js? And I know how I do HTTP requests in Node.js. There are plenty of libraries for this, but I have my favorite. It's called got. And I wonder if I can download a file using got. So it seems like it's no. The answer is no. Okay, so yes, while you were away, I was saying that I was going to start investigating something that maybe you have an answer for, but I don't, which is something we definitely need to do. We need to download a file using Node.js. And we need to do that in a cross-platform way, of course, because Windows support is essential. So you cannot simply maybe call wget, which is available on the latest versions of Windows, but I don't want to rely on that. So we need to download files using Node.js. And I went to my favorite HTTP library. So this is the library that I usually use to do HTTP requests. And I thought maybe they have a solution for downloading files, but a quick Command F didn't reveal anything. Do you have a way to download files in Node.js that you typically use?
It looks like they have HTTP2 support. My go-to would be something like Axios, but Got I think is newer and better even, and I think it supports streams, so seems like a reasonable choice.
Okay, so how to stream download files in Node.js with Got? Yeah, it seems like Got is able to do that. Reliable file download with Got. Okay, so that's something we need to explore, but there is another thing we need to talk about, and that is when we are going to download this file. I think I can think of two options. I actually could think of one option, and then on the stream last week, some people mentioned the second one. the two options are, we either download the file, the stub, as soon as you are installing the package. So when you say npm install caxa, there will be some npm script, a post install script of some sort that downloads the right stub, and that's the end of the story. The second option that people mentioned last week is that we could download when you first run caxa. So you don't download the stub at the installation, but you wait for people to try to run the thing and actually package a file or a project. And then you see, do I have this stub? No, I don't. So let me download it. Because yeah.
Well, I was going to say there's potentially one wildcard third option, which is you download it when you open the binary. Which is, I don't even know if that's really makes sense. But you could have like the binary would just be like the tarball of the package, and then you click on the binary, and then it downloads the code it needs to do the self-extracting stuff. But I don't think that would work.
Well, we would need some sort of stub that would be bundled with your tarball to be able to download the rest of the execution. I don't like that idea, because suppose you have a binary compiled with caxa, and you are offline, then your binary doesn't work for a silly reason. It already is. We are talking about Node.js projects, so most binaries are like 100 megabytes at least, because it is bundling a lot of dependencies. And then you have already a download that is 100 megabytes, and then you're just missing like 5 megabytes. Or I guess 3 megabytes.
Yeah, so let's rule that one out.
Yeah. So the options are to download when you install and to download when you run. And I can see advantages and disadvantages to each. To download when you install means we'll have a post install script of some sort, which can be annoying. It seems like people dislike post install scripts. And I think I am with them. I find them rather annoying. Sometimes they don't work, and it is difficult to manage, to figure out whether you have downloaded the thing already or not. So it is kind of messy when you run npm install in development mode, or when packaging for npm, when the GitHub Actions thing is running. So it's kind of annoying to have a post install script there. But if you install only when you run caxa to actually package something, then you have npm installed something and went on a plane.
Yeah.
Now you are missing that 3 megabytes that you needed to do your work.
Yeah.
So
again, the third option is that you download all of them, right? If they're not that big.
Yeah, so we could, and I mentioned this on the stream, we could just put all the binaries on the npm package, which could be okay.
I mean, how much do they amount to, all of them together?
So there are, I think, 7 of them. 1, 2, 3, 4, 5, 6, 7, and they are around 3 megabytes each, so 21 megabytes, which is not a big deal, but people didn't want to have a dependency that was that large. I guess probably for aesthetic reasons, but in any case. Also, we still have to figure out in which platform we are when we are selecting the binary, even if we have downloaded all of them. So I think that the problem of figuring out which platform we are in and figuring out how to download files using Node.js are just two things we need to do.
Yeah, absolutely. Makes sense.
Yeah.
What are you leaning more towards?
Most people wanted to download this stub when you run the first time, but I'm more leaning towards installation time. So I would like to give the post install script a try. I have never worked with an install script.
Yeah.
But if it's easy enough, I would like to try that, because then installing a package really means you're installing the package. When you install caxa, you have everything you need to work with caxa.
Yeah. My gut is telling me that it's going to be easier. I don't really have a preference from a user point of view. But my gut's telling me it's going to be easier to um, to build if we do it at runtime. Just because we'll be in the Node.js environment, we don't have to Google around for post-install stuff. But on the other hand, we'll be learning more if we do the post-install. So that'll be fun.
Yeah, so how about this? I propose that we start with a script, a Node.js script, that downloads the right file.
Yeah.
And so we'll have to figure out in which platform we are, and we'll have to figure out how to download files using Node.js. Then we'll figure out what we want to do with this script. We either will embed the script into the caxa, into the thing that runs when you use caxa, or we'll put this script as a post-install script. So let's figure out the core of what we want to do, and then we'll figure out when we want to do it. Okay, so let's start with the easy problem, shall we? Let's start with the problem of figuring out in which platform we are. So effectively the problem of building a string that looks like this, right? Because you can see on the bottom of my screen what the link looks like for the whole path we'll need to download. And it is fixed. It will be github.com/liafax/caxa/releases/download/ the tag that we can get from package.json, and then / the stub name. And the stub name has the platform and whatnot. So let's build this later part of the string, which is stub -- platform -- architecture.
Right. Well, I can do the stub bit.
And
cool. Go ahead.
Yeah, so we kind of already have the answer, because people who wanted ARM support wrote, first of all, an excellent pull request, which we merged last week, but also an excellent issue description here that pretty much covers everything. So they have already figured out what we need to use.
Yeah, there's Node give us for this. Oh, process.arch. Yeah, cool.
Yeah, so
okay. Nice.
Let's jump here into Visual Studio Code, and I am on the master branch, and I'm going to not look at the source right now. I'll put this on the root, and this will be the David script.
Oh, nice.
And in here we'll have, so that's another thing the stream may be interested in knowing. David suggested this live share thing for Visual Studio Code, which I wish I knew about last week when I was working with Matt. But yeah, it seems super cool. It's my first time working with live share. But we can all write together, and it's like Google Docs, but for Visual Studio Code.
Annoying that it doesn't say my name. But yeah, cool.
Yeah, it doesn't say your name. Maybe I can do something about it.
I can see your name. I think it's because you just gave me a link. Anyway, we can fix it another time. Maybe for the next time we do this, we can look into that. But yeah, it's not super high priority.
But there is only one guest anyway, so
there's only one guest. Yeah, it's kind of clear. Cool.
So we already know that this is going to give us the architecture, and this is going to give us the ARM version. And I already know that we can look at process.platform. This one I know because we use this elsewhere in caxa. So there is process.platform, which tells us the operating system. And yeah, so let's build this string. Oh, you are already putting everything in place right here. So that's awesome. So we can look at platform arch, and we can also look at config and then a bunch of stuff. So where is it? Oh, man.
Yeah, I'm not sure. I think we're going to have to look at the docs for what bit is what, but...
No, so yeah, we can look at this guy. There in the issue, someone mentioned this. So process.config.variables.arm version, which of course is only useful for ARM, but...
Yeah.
I can console log that.
I think we're probably going to have to,
And I'm already interested in knowing what this will output. So I can run David. And it says the
actually see your
platform.
console, by the way. It's very cool.
Sorry?
Okay, I can see your platform, by the way, which is very cool. Can I run it on mine, and will it do something different? Oh, I don't know if I can. I know, we'll just run it on yours anyway.
Yeah, I think you have access to my terminal so that you can run stuff on my machine.
Yeah, I don't think I can type in your terminal right now.
Oh, maybe I need to enable that explicitly. So yeah, the terminal is read-only, but I can make it read-write.
Exactly, yeah. Yeah, but it will just, yeah, I can do it now. But yeah, it's still just executing on yours, I'm pretty sure.
Yeah, so I think that the way we want to do this is, how about we build an array of the platform? Oh, and by the way, last week when we were building the stubs, I was, I'm gonna say smart enough to use the right names. So now the stubs, when they have their different names, like Darwin and Linux and Win32, because process.platform gives us Linux and Win32 and Darwin. So we don't need to do any translation.
Yeah, thinking ahead. Nice.
Yeah, so I think what we can do is we build an array of all these 3 pieces of data, and then we filter this array to look at, I don't know, some information part so that the information is not undefined. And I need to wrap the line here because it's behind our faces. Yeah, so I just did a quick formatting here.
I added stub, but I don't know if you want it in there. The idea was that you would just join them at the end.
Oh, yeah, exactly. That's what we are going to do. And then I'm going to join with dash dash.
Cool. Yeah, it was double dash, wasn't it? Yeah, you can delete my function. We don't need any.
Yeah, and I don't think we need the console logs, but we need to console log. Or actually, I'm going to.
Do we want to validate that it is one of the expected ones?
Well,
I guess we can validate that later when we fetch.
I think we can try to download, and if it fails, then it means that you are, for instance, running OpenBSD.
Yeah.
And we don't have support for OpenBSD yet because no one asked for it.
Yeah, we can 404. Yeah, cool.
Yeah, so stub, Darwin, x64, and I think that just for fun, because this script is just pure Node.js and it's so easy to use, I think just for fun, here's what I want to do. I want to test this on a Raspberry Pi. And of course, I don't have a Raspberry Pi, but I do have Docker. So I'll start Docker real quick and we'll run the image that we used to test on my machine. And then we will pretend that we are in a Raspberry Pi and run the same file, and then we'll see a different platform. And I'm doing that just for fun, to make sure that everything works.
Yeah, cool idea. Let's do it.
Yeah. So here is the part where we are building with Docker.
Mm-hmm.
And I will copy this command into a temporary buffer and look at, I don't think we need this platform part. That is for when you're running Docker in Linux and trying to use a different architecture. But in macOS and Windows, we have Docker Desktop. So we don't need this part.
You're not on the M1, are you? Oh, no, we saw that already. You're x86.
Yes. I do have an M1 machine in which we could test this. It's the streaming machine, the machine that is connected to YouTube right now.
Oh, right.
But yeah, it's the streaming machine, not the machine that I'm using to develop right now. So are you familiar with Docker?
I was thinking about that string, caxa. Does that have enough entropy? Like, is it not possible that the archive could output those ASCII characters?
Yeah, so we thought about this last week, and I actually changed this string last week. So the story here is, this is the separator. So this is a string that appears in your caxa executable that separates the stub from the tarball containing your project.
Mm-hmm.
And we are looking in the Go stub, we are looking at this as a data structure, and we are looking for the separator from the top down. Mm-hmm. So it means that in the binary of the stub, so when you compile Go and you produce this stub binary, that binary must not contain the string caxa, caxa, caxa. And the way I managed this in the past, and I think we'll be able to continue doing that, is in the Go code. This is actually a hack, but it's super interesting the way it works. In the Go code, we generate the string using repeat.
Yeah.
So here there was a separator that looked differently. It was pound, 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 caxa, pound, pound, pound. But now it will be caxa, caxa, caxa because we wanted to get rid of the special characters. So what we'll do here will be like repeat caxa 3 times, something like this, because
by
doing this,
find the same string if it's like compiled.
So this will generate bytecode that does not contain the string caxa, caxa, caxa in there. And that's what this comment is even explaining. Now, it could be possible that the Go compiler could be smart enough to detect, oh, this is actually something I can do at compile.
Yeah.
I can optimize this away. And I looked at the binary produced by Go when I was compiling the stubs, and I inspected the thing, and I determined that, at least for that version of the compiler, at that point in time, it was not optimizing this away. And we rely on that for correctness of cache. But, I mean, trivial tests that we are running on GitHub Actions would pick this up if this becomes a problem.
Well, I was more thinking, like, just even the tarballing, like, there's just a lot of characters which are generated.
Well, that's not a problem.
Because it's not looking through that bit.
Because it is looking, this Go function looks from the top down.
Ah, okay.
So it's going to find the first occurrence of cache.
Got it.
Or cache, cache, cache.
Got it. Okay, cool. Makes sense.
So yeah, we were here and we were figuring out which command to run. So are you familiar with Docker?
Yeah, somewhat, yeah.
Okay, so we are going to run a Docker container. We are going to remove that container right after we are done. We are going to mount a volume, which is the cache project we are on right now, into the cache folder in the container, which will also be our working directory. And then for the Docker image, we need to pick an image that, this right here. Let's look at the image. For instance, let's run on maybe this version.
All right.
So this will run on ARM7, which I guess is the processor you would find on a Raspberry Pi 3 Plus, for instance.
Okay.
Not really sure. I have never even bought a Raspberry Pi. I was considering buying one for developing cache, but then I learned that Docker can emulate it so well that I never bothered. So this will, let's maybe run bash, and then we can call Node.js from there. So yeah, let's see if this works.
Okay.
So it's going to install the image, and oh, that's too bad. Oh, and there's another problem. We don't want to run we have two different containers, one for building that has Golang and one for running tests, which has Node. And in this case, I want the Node version. So let's go to test, Linux ARM, and grab that one.
Are these ones that you're hosting, or these images?
You mean the Docker images?
Yeah.
No, these are images that Matt found, and these are images that some other people maintain. He said that either the maintainers of Docker or the maintainers of Node are behind this.
Okay.
Either way, I'm more than happy to use pre-built images.
Yeah, for sure. We can trust them. Hopefully.
Yeah, and it seems like this one will work on my machine. And it is a somewhat big download, so maybe I should have chosen the other one that is based on Alpine. Probably smaller.
Yeah. Oh yeah, Alpine. Alpine's always good.
Oh, it downloaded the whole thing just to tell me that it doesn't match the host platform. Okay.
Classic Docker.
It's say, and no specific platform was requested. So maybe the mistake is just that the thing I deleted was actually important.
Yeah, that makes sense.
So
It
put it
should
here.
have everything cached. I'm not sure. I think maybe it only caches if it succeeds.
I think it will have everything cached. It will not try to download again. But let's look. The platform will be Linux ARM. I'm so
Mm.
glad that Matt figured out all these things. I would never do it myself. I would probably just cross compile and hope for the best. Okay, so
Oh,
that
okay,
worked,
cool.
but I forgot to say -it to get an interactive shell, so I'll
Oh,
do that
yeah.
now. And now
Oh,
we
is
are
it not?
in
We got
caxa
two.
and we have the
Yeah.
whole project and we have Node version 16 installed and we can run David in there and we'll get the stub Linux ARM 7, which
Nice.
exactly matches the stub name. So it seems like we
Cool.
figured one part of the equation. We know how to build this string.
Hmm.
I mean,
Awesome.
uh,
Success.
yeah,
Right.
let's do something else here. Let's just go to the package.json file and get that part because we know we are going to need it to build this string here on the bottom left. We'll need the tag version, so that's easy, right? We can just const package equals require package.json, and I specifically will want to do this with an absolute path. Or do I need to do that with an absolute path? I think I can do it just like that, right?
Yeah, should be fine. Yeah, shouldn't have to do any magic to open a JSON file, to require a JSON file.
That should work, yeah. The only concern I have is what happens if you run this from somewhere else? So let me just, first of all, make sure
Right.
that when I change a file here in my machine, it also changes in the Docker container. It should be in sync, but let's
Okay,
double
yeah,
check.
yeah,
It is in sync
yeah.
because we have that line.
Nice.
And what happens if I am, for instance, right above and I'm right here?
Yeah, this should work.
So when I say like console
Cache,
log
David.
of package dot version, for instance,
Mm-hmm.
and then cache David, that gives us the version number. So that is
Cool.
relative to this script,
Mm-hmm.
which is exactly what I want. So
Yeah, that's what you'd hope for.
yeah. So now let's build the whole string. Why not? So I'll copy one of these.
Yeah, there are no special cases. They're all 3-part. Although I'm a bit confused. Some of them must not have an ARM version, so what would they return?
You mean, for instance, Win32? It doesn't have ARM, right?
Yeah.
It will return x64.
Okay, cool.
But then the ARM version will be undefined. For instance, in my machine, it's undefined, but then we filter it out.
Oh, yeah, we do filter out. Yeah, that's cool.
I want to change this variable name. It's not very descriptive.
I'm like, for such a small function, I would just do like the identity, just like x to x,
Okay, x.
and then the second part can just be x. Like,
You don't need this, right?
it's just truthy. Yeah.
That I'm more uncomfortable with because I'm relying on the fact that in JavaScript a string evaluates to true, but an empty
But
string doesn't.
well, then you should be testing for like is nil, I suppose, because it could. How do you know that it returns undefined? You could. It probably does, but it could return null for one of these, right?
I don't think it.
Or
I don't think
an
it
empty
will.
string. No, I don't think it will either. But
Yeah, look at that. It will return a string.
okay.
And Arch will return a string. At least that's what the TypeScript people think.
Yeah.
And then ARM version is not even here.
Well, there you go. The types aren't up to date.
Yeah, but that's okay because it will be undefined.
Yeah.
I like to avoid the JavaScript bad parts as much as I can.
Truthy. Yeah. Okay. Cool. All right.
So here we have a template of the string, and it will be in liafa caxa releases download, and then in here we'll put the package dot version, and then in here we'll put the stub, and of course this needs to come later, and here we can get rid of that and format the whole thing.
Okay.
So I think that I should run this and produce a string that I can command click on and have my browser ask me if I want to download something. Nope. Okay, and that's because I have not published this version yet. Or actually, when I published this version was didn't have the stubs. Right? This is a previous version that did not have this.
Oh, okay.
The whole GitHub action situation happening.
Okay, makes sense. Yeah, what was the full string that we're looking for?
Oh, but everything else about the string makes sense.
Mm-hmm.
We are getting the version, we are getting the right stub and whatnot. So everything else in here makes sense. So now we need to figure out a way to download something. Oh, in fact, I'll say that this is like, I'll create a variable name here that I don't know exactly what to call it. So I'll call it David. And here I will hard code the path to the build that does exist, the one that we are looking at right here.
Yeah.
So that we can actually download something by the end of the day.
Yeah, makes sense.
So we know that we want to get rid of this variable at the end, but for now, we can console log David instead. And I'll have here a download path variable.
Should we move this little function into a function?
I guess we can figure that out when we decide what we are going to do with the script, if it will be a post install or if it will be something that goes into the project proper. Because if it's something that goes into the project proper, then this probably will be a parameter that you can pass on the command line that has this as a default value. Because you could decide to download your own stub, or you could decide not to download any stubs. Right? I don't know what we are going to do with that yet, but this thing we have right here,
think about it,
I should now be able to click on and have my browser ask me if I want to download something.
Yeah, exactly, yeah.
So now, let's try to download this using JavaScript.
Yes, you should just go for got. So yeah, what are the...
So we can either do got download file, or we can do Node.js download file.
Yeah, just stream it.
Download file downloader. So this is kind of boring, the thing that we are about to do. We are going to find probably a package, maybe a way to do it without a package, but probably a package. And yet I find it so important, especially in JavaScript, to show people how to find a package, because it's sort of an art form to find which package you actually want to use.
Yes.
So you do this together. You mentioned Axios, which is a good package, and I also want to look into that. On download progress. Yeah, it seems like this on download progress is also something that exists here. But I'm not interested in that. I'm not interested in having like a progress bar of this download. It's 2 megabytes.
Is there any way to, like, if we need to resume the download, do we care about that?
I think we care about that. And I think that the way we are going to manage this is we are going to check whenever, either in the install script or later when you're actually running the project, when we decide that we need to download this file, we'll look at the checksums file, because we produce a checksum file. Where is it? Oh, I think I closed that tab. But when we run the GitHub Actions, we produce a checksum file.
There seemed to be one on the previous page, like checksums.txt. Was that what you meant?
That's the one I mean, yes.
It was in the tab to the left.
Yeah, so this file is here, but it's also going to be shipped with the npm package. So when you say npm install, you get checksums.txt.
Mm-hmm.
So the thing we are going to do is we are going to look at this checksums file and look at the place where we would put this stub. If the checksum matches whatever is it at that place, then we're good to go. Otherwise, we delete whatever is there and put our thing there instead.
Okay.
So if the download fails, the next time you try to run the thing, the checksum will not match, and we'll just delete the file and start over.
Oh, okay. Yeah, I was thinking more like if we would be able to somehow like cache chunks of the download, but I don't think that it's such a small download that I don't think it's necessary. Like
Yeah.
you're thinking if it fails halfway through, like we want to make sure that we don't have the like a broken version downloaded and try to use it, which yeah makes sense.
Yeah. So yeah, that's another thing we have to do, and I forgot to say. So we have to download a file or download the download path file using Node, but we also have to check the checksum.
Mm-hmm.
We will have that file there, and we want to make sure that it matches whatever we downloaded.
Mm-hmm.
By the way, I kept mentioning this last week, and I don't know the answer for this. Do you know if there is any notion of trust when you download from npm? When you npm install, how can you make sure that you are not a victim of a man-in-the-middle attack? Do you know if there is some sort of checksum or signature in place?
No, quite simply.
I don't think there is. I think that there may be. But I don't think there is. I don't know how it works. So maybe...
Isn't it just HTTPS, TLS, and you just verify that?
Yeah, I think. So maybe the thing that we have here with the checksum is even more secure than what you do when you npm install. So anyone could man in the middle and figure out this checksums file, change it, and then point you at a malicious stub. But that's a problem for someone else.
Yeah, I mean, I guess we could sign it with HMAC or something, and then, but then somebody could change the signature that we're verifying it with, and whatever.
Yeah.
I don't know. I think that's the least of our concerns.
Yeah. So
to be honest.
This is a simple utility. Okay, this is a contender.
Yeah.
Using HTTPS and FS by hand.
It's I don't.
It's not terrible, but I don't like it.
It's okay. It's just a stream, right? I mean, if we do that, maybe we just make a really quick utility for converting streams into a promise, which is really not hard to do and very useful.
Yeah.
In general.
Yeah, and it even comes with Node starting version 15.
Oh, yeah?
Yeah,
Cool.
but I think it makes sense for... yes, in Node, I'm pretty sure that it started in version 15, but we can check the streams documentation real quick, because there is a promises API that started in 15. So yeah, you can say streams/promises.
There you go, yeah.
So that could be something, but I think that it's good for us to support Node 14. So I don't want to use this one. But in any case, that should be relatively easy. But there is another concern here. We can use a package, or we can do this without a package. My question is, if we decide to use a post install script, are the packages available when you do a post install installation? I suppose it is, because it's post install, so everything should be already in place and we should be able to use whatever package we need.
Yep.
But I don't know.
I like your logic, though. It does make sense.
Yeah. So I think it should be safe for us to say that we can use a package if we want. So there is a Node download helper library, and it's called Node helper library. It's a library called library.
Oh, okay. That looks promising, because, like, hopefully it's just like a wrapper to be just sort of backwards compatible and doesn't do much else. Try GitHub. Prefix GitHub. Well, it's got a GitHub link normally in npm as well.
Yeah, it's not a library really. So the person is saying npm install, and that's not something. Oh, there is a library called download.
Okay.
So we already have two. We have Node.js file downloader. We have download. Oh, download is popular.
Okay.
Let's come back. And that's all for this article. Don't need this tab. Node fetch. Oh, okay. Node fetch is an implementation of the browser fetch API.
Yeah.
So that's
I
something.
mean, is it a consideration whichever is the smallest?
Not really. I mean, this is only for people who will be packaging using caxa. So I assume that when you actually build your application, you don't include caxa, right? You remove the...
No, yeah.
Caxa would probably be a dev dependency that you prune. Yeah. So yeah, you can use node fetch, but node fetch is just using a stream under the hood, so that it's not too appealing. I don't like that. So this is using request, which has been deprecated, but it's also just using a stream and using got, streaming a file.
I mean, I guess it's going to be nice if it streams into a file.
Yeah.
Like
I'm very happy with this approach.
Yeah, for a moment I thought we were gonna put it all in memory and then write it out, which we could also do. Yeah. And that would save us having to do the checksum check as well, actually, because we'd only write it when it's complete.
But we need to know whether we need to install it in the first place.
Yeah, true.
Handling progress and errors. Okay, so I think at this point I'm sort of happy using got.
Mm-hmm. Yeah.
But just to make sure, I will take a quick look at the rest of the article. So there is the download package. It is based on got. And then some people are having some issues with it, whatever. And then there is Axios. So, oops, didn't mean to do that. So let me close a bunch of tabs here. We don't need this anymore. This we may need. And then we have got.
Mm-hmm.
Oh, and then there is a link here on how to do that from 9 years ago without using libraries. You do a stream and you pipe.
Yeah. Which is not so bad.
It's not terrible. I mean, I'm okay with that. So, okay, so you have here 4 options, or actually 5. We can do it natively with got, with this guy, and that one, Axios. How do you usually go about choosing a library or choosing not to use a library?
The more stars, the better. No. Well, that's actually not a bad consideration, to be honest.
It's not.
It depends what it's for, I suppose. I think if it's going to be like fundamental to the entire architecture of the application that I'm building, say it's like a UI framework or it's like the ORM, then I probably want something with a lot of stars and a lot of downloads, which has a lot of support. I don't want to have to monkey patch the APIs or anything like that. So that's probably a big consideration. And then sometimes it's just, I don't know, sometimes it just makes sense because it just does it neatly. I could build it myself, but then I've got to maintain that small thing, and it's just neatly packaged away, and it encapsulates whatever the functionality that I need. I don't know. How do you normally decide on which package to use?
I think it boils down to the same thing: popularity. which I can measure by the number of starts, the number of downloads, the number of issues and pull requests, the number of forks, the number of commits, that sort of thing. Also, I must admit, aesthetics. Sometimes the README just looks amazing, or they have, for instance, Axios seems to have a page that is dedicated to the project, and look at this, it looks professional. So
Yeah.
I must assume that whoever is behind this is a professional, and that's what I want.
Another important consideration are the number of GitHub issues and how recently there was a commit. If there wasn't a commit within, there's a joke that like if there wasn't a commit within the last 30 minutes, then it's no longer, it's been abandoned, you know.
Yeah.
But like, you know, if you see like commits within the last few months or the last year, you're like, okay, it's pretty active. And like how many, I don't really look at the closed issues to open issues, but if they're like all the issues that just haven't been responded to, and it's like, is anyone even working on this project? And it's just like nobody's responded, which I have happened with a few libraries that I've used. Then I'm like, oh, stay clear of it if I can.
Yeah. And there's this tool that I use to measure how popular something is. Have you run into this before?
I have, yeah.
So it is something that shows you, it plots the number of downloads of multiple libraries. And you can just say, we are interested in GOT versus Axios versus node file downloader. That's explicit.
Yeah.
And it even suggests related libraries. So people who looked for GOT also looked for request.
Interesting. Yeah, to request was another one. There's another website, I forget the name, but he's working on this. Like this is like his whole thing is like working on how do you evaluate a library and sort of, putting all the metrics there in one place. NPM, it's similar to NPM trends, but it's like almost like an e-commerce kind of holistic system about finding node modules. I will look for it in a bit and I'll link it to you to be honest, I didn't find it that useful, but I think the interesting thing was that it's like it is a problem in itself.
Yeah. I mean, the best part of the node ecosystem for me is how popular Node is, which has all these other nice things that fall out, like the number of libraries, the number of people who get interested in your projects, the number of people who may contribute to your project, and so forth. But it's also one of the downsides because there is so much choice for everything you want to do. There are 15 libraries and you have to figure out the one that you like. And there is no like Rails. Everyone who uses Ruby uses Rails or uses Sinatra or whatever, but there is Rails. And as long as you are in the happy path, you can use Rails and you don't have to worry about any of these other considerations. But given a chance, I will go Node.js every time. I like the options and I like figuring things out and maybe coming up with a new solution myself, which is what happened in Caxa. So anyway, in terms of
it's a good problem to have in general.
Yeah. So in terms of popularity, we have GOT and Axios at the top, and they are both libraries to do HTTP requests. So they are more general. And then there is download and Node.js file downloader, which are specifically for downloading files. So in this case, I would go to download first because it's the most popular that solves specifically the problem that we have. And it is wildly popular. So maybe we can look at this and see if the way that it works and see if it makes us happy. So
I imagine just because it's smaller, and like I know you said it's not really a consideration, like the size, but like I guess it would just take less time for people to install our package, which I mean I don't know if that's a huge consideration, but why do they reference GOT documentation there?
It seems like we saw this mentioned, I think in Stack Overflow somewhere. It seems like download is built on top of GOT.
Oh.
So it seems to be like a simple wrapper around GOT that will hide away the stream. And I think I would go with a line like this.
Yeah.
I want to give this a try.
It's pretty. Okay.
Sure. So not in
Docker.
It doesn't really matter really, but
yeah, okay. Yeah, true. It actually doesn't.
But I will install this locally, so I'll install download. I also like the name. It couldn't be more explicit.
Yeah.
And
Yes.
that's another consideration, really. That's another consideration. If there is a package named cookies or download, or
Yeah.
it means that they got early in the game. So they
Yes.
have been around for a while, and if they're still around, they must be good.
I was thinking about this a while ago, like domain squatting, like is it illegal to do npm package squatting and GitHub repository squatting? I'm sure there are some terms of service there which you can break, but yeah, if you get to the game early enough.
Yeah. So we have download the package. It is downloaded and installed, and now we can
Download.
download stuff using download. And I will do this with async await. So
I don't think we need the whole.
we don't need the whole thing, but I do need parts of it. So I think I need just this line, really.
Yeah,
And then
makes sense.
I'll put this under stub. So we have different stubs for the different platforms, and we are picking the right one with the download path, or David.
Hmm.
But then we only want to download the right version for a platform, and we want to put it at the same place every time.
I I would say, by the way, you know how you're like, oh, I don't care about the on progress event.
Mhm.
You might do like you might. I mean, how long is it expected to take to package?
Couple
Um,
seconds,
okay.
less than a minute for sure. Because packaging boils down to creating a tarball and appending a tarball to a file.
Yeah.
So await
Okay.
download of David.
Mm.
And this is getting out of hand. So here's what I'm going to do. I'm going to comment out download path, and I'm going to say that this is download path.
Mm-hmm.
And I'm putting these comments later. And just to make sure, it seems like everything is okay. So right now, looking at my root directory, I don't have a stub right here, but then I go into the Docker container because it doesn't really matter.
Yeah.
I will go into... Oh, so this is a place where we may want to put an absolute path.
Yes.
Because here it would download into the root of the Docker container. So let's...
Would it?
I think it would, because it would look at this file name and it would make it relative to where we are right now. I can check this, it doesn't hurt. So I can say node caxa David, which should download the file and put it on the root, I think.
I think it will do it relative to David. But if you do // I reckon it will do it relative to David. But you got an error.
Yeah, the error is I forgot to say this.
Import fs, yeah.
And I don't want to write file sync because I am in a sync await block. So I'll wait for write file, and I'll use fx extra. I am already depending on this, I think.
Oh, okay. Yeah, I was going to say it doesn't seem standard.
Yes, I am depending on this already.
Okay.
Probably for good reason. So I'll just use that because we are assuming that the download package will be available. So the FS file system extra will be available as well. So I think we can just use that, which has the asynchronous version available for us. Otherwise, I would have to use FS promises, but that is unavailable in Node 14, which would be annoying. So FS extra. And IDDQD sound says on the chat, sitting here pretending to understand what's going on, lol. Thanks for joining us. And if you want to ask specific questions, I'm more than happy to answer specific questions.
Why don't you want to do it synchronously?
And because I'm already in an async block, so it seems more proper to do asynchronously. Not that there would be multiple things running anyway.
Yeah.
Doesn't really matter, but it seems like download is hard-coded. Download doesn't have a download sync option, I don't think.
Yeah.
Yeah, I wouldn't expect it to. No. So since we are already doing things asynchronously, I prefer to do everything asynchronously then. So we downloaded something and it put it on the root. So that's not what we want. What we want is to...
Oh, you are right then. Okay.
So let's do the thing where we just
if you
say...
do dot slash.
Let's
Yeah,
say just dot slash, and then we'll see what it does.
Yeah. I reckon this will be relative,
Okay, place your bets. I think it will be in here,
yeah.
and David thinks
In
it
the
will
root?
be relative to the path of the
I think
script
it's got to
itself.
be consistent with the require package.json at the top.
No, require is a whole bunch of magic. In require, you don't need to put .js at the end. In require, it looks at the node modules folder. In require, you can do things like loading JSON and it will parse the thing. In require, it is crazy the amount of things that require does. But write file,
circular dependencies.
yeah, it deals with a lot of things. Require is crazy magic that Deno, the other JavaScript engine from the same creator of Node.js, Deno tries to remove some of this magic.
Mm-hmm.
And also the whole ECMAScript modules situation also tries to get rid of a bunch of this magic, but require is super magical. And I think that this will list stub in there. And it does. I was right.
Ah, okay. Yeah. All right.
So
Nice.
we'll have to build this absolute path by hand by using
Yes.
path, require path, and then here we'll path join
Mm-hmm.
with their name.
Their name. Oh, jinx.
And I think this is relevant because if we decide to run this as a post install script, I have no idea where the working directory will be in that situation. So now let's check. And there is no stub in here, but there is a stub in the root of my project.
Cool.
Which is already in the git ignore. We did that when we were building the stubs.
But slash stub?
Because I don't think that's the case, but if we had a stub file, for instance, in here, for whatever reason we decide to have a stub file here that says hello, this one is not ignored.
Right.
In the source directory.
Okay, right. So this is at the root. Okay. Yeah, makes sense.
Yeah.
Okay. Yeah.
And interestingly, I was running this in Docker, so it means that this stub we have right here is not the stub for my machine. It's the stub for
Oh, yeah, of course.
Linux ARM.
Okay, sure.
So download the download path using Node.js. Check.
Right. Now check the checksum.
Now let's check the checksum. For that, we will need a checksum file in the root here or somewhere. And I think it's good for us to have this on the git ignore as well.
Yeah, you said you were planning on packaging it for npm, so it's there by default.
Yeah, so it will be there in the package, but during development it will not be there. So I'll have to come here and download this file by hand.
Yeah, okay.
And I just did that, and I'll show in Finder, and then I will move it to my code, caxa. Yeah, just the root. Move it there. But it's still in the git ignore, so it will not show up here. And then we can look at the checksums file, and we need to get...
How was it generated, the checksums file?
It was generated in the GitHub actions, but it was generated using some algorithm 256 of a folder, and in this folder we had all the stubs for all the platforms. So we run all the compilation steps in all these different architectures, and then we put everything in one folder and run this with Checksum 256 star.
So has it got like on each line it's got a different checksum for each file or in the folder or something like that? I don't know what the structure of it's going to look like. Oh, okay. So we have to pause it?
I suppose we have. We could use Checksum on the command line to check the stub. As long as it had the right name, the Checksum executable has a way to check. If you have a checksum file and file, you can check it. But here we have renamed this so it's now called just stub. And also, yeah, I guess the main problem here is we have renamed the thing, and also we cannot really rely on Checksum being installed. So we'll have to do this using Node.js. So we'll have to parse this.
Any reason why you chose Checksum 256, or were you evaluating other algorithms, or it's just the standard? Or
so I think that Matt started this with MD5. And I remember saying on the stream, or maybe on a GitHub issue, that MD5 is sort of broken. Let's use SHA. And he didn't even talk about it. He just changed the pull request. He did this part. And yeah, SHA because
what's broken about MD5?
It is prone to what is the term? Conflict? No, it's not a conflict. It is a collision. Yes, it is prone to collision under very weird circumstances. But it's not a big issue. But yeah, SHA-256.
It's one of those things which has been like proven to be possible in theory, and therefore SHA has been proven not to do that. And so it's like, it's better. SHA's better.
Yeah, it's just one of these things. Cool. I think that even Git uses MD5 under the hood, or at least used to use MD5, and they wanted to change that to use some sort of SHA.
Mm-hmm. Have you ever implemented a checksum algorithm yourself?
I happen to have done that in the past. Yes, I took a course, or actually 2 courses in cryptography, and then I had a side project, a qualifying project on my PhD that happened to be with sort of a big name in the cryptography field. So I worked in cryptography for a while in the intersection of programming languages and cryptography. So yeah, I have implemented simple versions of all the cryptography algorithms you would expect, like encryption, decryption, signature, verification, key derivation.
Cool.
I don't even remember some of the terms, but I have implemented hashes. I have implemented asymmetric cryptography as well, so
nice.
Public and private.
Would you be interested in elaborating a bit on how a checksum works, or should we just crack on with, it will take too long, crack on with finding out how to...
No, it's actually very simple. So the way a checksum works, or a hash function that we are using for the checksum works, it is... On a high level, what you're doing is you are taking all the chunks of the thing you are hashing. So if you have a file, you're taking all the chunks. And let's suppose that you're taking chunks that are 8 bits in size, whatever. And then you just route these bits to 8 different bins. So you have 8 bins. Okay. I'll do it like this. I will start drawing a cute little ASCII diagram here. So you have...
Draw.
Oh, we could do that, but...
Another time.
Yeah, maybe for tomorrow we can set this up. So let's say that you have a file that has... I'm breaking it apart. So you have a big file. I'm breaking it apart into these bins. And then I come up with 8 bins, and I take like... this number 1, and I put it here, and
so these are chunks.
That number 1, and I put it there, and the other number 1, and so on. Okay, so I'm just shuffling the thing around.
Yeah.
And then let's say that I add all these bits. These bits are the bit number 1 from this part, the bit number 1 from this part, the bit number 1 from this part. It's just a bunch of bits. So let's say that these bits actually read like 110, and I add everything together. And okay, so this is binary addition without a carry. So it becomes 1 plus 1 is 0, plus 0 is 0, plus 1 is 1, plus 1 is 0, plus 0 is 0. So I put...
just anding them all.
And you are XORing them all, I think.
XORing them all. Oh, yeah, okay.
So you end up with a number here. But the cool thing about this number is that it is influenced by the first bit in all the chunks. And similarly, you would, of course, do the same for the part that is the second bit on every chunk, right? So you end up with this string of zeros and ones here that is influenced by your whole file. And of course, if you need to have smaller and smaller hashes, you just iterate on this idea, right? But the thing here is, if you change just one bit in your file anywhere, this is going to percolate and it's going to influence your hash. And of course, an important part of the hash is that there is some feedback. So when you iterate on this idea, if you have now, you're going to end up with 8 bits, but you could iterate now with 4 bits, right? And you would iterate on this. But the smart thing is that you have a feedback loop so that this string...
It's like a tree.
Sort of, yes. So you can look at this result and do the same thing, just with this result instead and fewer bins. But you introduce a feedback loop in which maybe this bit will be shuffled to the right and this bit will be shuffled to the left. So now, as you do this again and again and you introduce this feedback loop, if a bit changes in the beginning, it doesn't only affect this bit, it will affect this bit, but also this bit will affect on the feedback loop the other bits on the thing as well. But it will do so in a deterministic way, so you don't introduce any randomness in this process. You always wire, in this feedback loop, you always wire the same bits to the same locations.
Right.
So that any bit in the input will influence some bits in the output, but you don't know which ones exactly. That's why it's secure, and that's why you cannot reverse the process. Because there is this feedback loop, and it's really hard for you to undo this scrambling of the wires.
But if it's a deterministic wiring, then you should be able to reverse the wires.
The problem is the feedback loop. Because when there is a feedback loop, there are multiple inputs in the same wire. Right? I cannot really draw this, but when I'm saying feedback loop, it means that maybe this bit, the next time I iterate on this, maybe this bit will be used as an input to this bit as well. So maybe we AND these two. So maybe we XOR these two. But we always do it with this guy and that one. But we are XORing this. And it is really hard for a computer to trace back this path, because each time you're XORing this, it could be 0 or it could be 1. So you have to follow both paths. And you have to keep following both paths to figure out which way this came from. So you have to do this thing that is exponential.
Yeah, that makes sense. Because like the feedback loop bits could come from any 2 chunks, and that like exponentially increases the number of bins that any feedback loop bit could have come from.
So the idea for the hash is this one, and the actual implementations of actual hashing functions are sort of simple. The hard part is figuring out how to wire these things to guarantee the properties you would want. Like, to guarantee that the only way you can figure this out is by exponentially trying both branches of this tree. And so to come up with a hashing function is super hard, and there are all these very smart people, cryptographers, not computer scientists, but mathematicians and whatnot, figuring out and proving properties about these hashing functions. So, okay, it's really hard to come up with SHA-256, and there are even competitions of cryptographers trying to come up with different hashing algorithms that have the right properties, security and performance-wise. But once you have written this specification, you can come up with an implementation for it relatively straightforwardly, because it's not that much code to write, and you just have to carefully wire all the parts together in the right manner. But the resulting code will be somewhat straightforward to read and very short, typically.
Wow. Cool. Well, I guess, fortunately for us, we can just choose the GitHub repository with the most stars.
Yeah. We don't even need to do that, because the crypto library, and that part I know off the top of my head. The
Yeah,
crypto library
Node.js.
in Node.js does have hashing functions. I don't know if it has the right one that we want, but I know it has some.
Yeah, it does. It does indeed. Have you looked into the web APIs, the crypto web APIs? There you go, SHA-256.
Yeah, but this one is for HMAC. But look at this. This
Oh,
is new.
CJS CSM.
Yeah, it changes your imports from CommonJS to
Right.
ECMAScript modules. That's new.
Nice. Yeah.
So let's see. I want to see SHA. That's create hash. Oh, seems like this is the one I want. So let's
Yeah.
go to.
Digest. Yeah.
So to check the checksum, we have to do two different things. We have to hash the file we just downloaded, and we have to parse checksums.txt. I'll start by hashing the thing that we downloaded,
Okay.
because that's easy. All we have to do is require crypto, and under here we have downloaded the file, so we can create hash SHA-256, update with await fs read file of this, and this is not UTF-8. I suppose that binary will be the default, and then take the digest, but I want the toString of the digest because I think that the digest will return a buffer, if I remember correctly.
Yeah.
So you were changing some things while... oh, you were parsing the file. Awesome.
Yeah.
Okay, that's great. So what you're doing here is you're splitting by new line. You are finding the line that contains the download path. No, not the download path, the stub.
Yeah. So we want to find stub name, like return name equals stub name, which will have to be a parameter at some point.
Well, we already have the stub name. It's the stub variable. It's right here.
Yeah, we can pass this in.
Oh, you're making a function. Okay.
Yeah.
Okay,
And
so
then...
while you're writing this function, I want to test that the thing I downloaded makes sense. So I'll comment out the part that actually downloads the thing because we have downloaded it already. And instead, I will just run this, which will print something to the standard output. So let's run David, the script again. Oh, it's your part of the code is not done yet, so it fails to run, of course.
Oh, really? Okay, sorry. I'll be really quick.
No, don't worry. I'm wondering if there is a way for me to just... Oh, so check this out. Can you write without syntax highlighting and autocompletion?
Okay, I'm finished.
Oh, okay. I just put comments around your part. Okay, so let's run this.
Sorry, I'm concentrating. Digest.
And create hash is
Okay,
not
you need
defined
to-
because it's from crypto, so I have to say crypto.createHash.
Yeah. Do you care about like which encoding you toString it from, or toString it to rather?
I don't care. Crypto is undefined, which is a typo.
Yep. Why do you not care? Because it will just do it correctly.
Oh, no, I thought it was going to do it in a way that would be readable, but I guess I do care about it. So now I need to hex. How do I take the hex out of this?
Like, do you provide hex as an argument to toString?
Ah, okay. Sounds good.
Okay, cool.
Oh, you were asking? I thought you were asserting, but you were right.
It was a bit of both.
Okay.
It's like I was kind of half remembering it, and I wasn't sure if I was right.
Oh, look at this. Look at this.
Oh,
This is
wow.
crazy. I didn't know this. But when you're running both ARM6 and ARM7 in the Docker containers, you're producing the same binary, which is stupid. That whole shenanigans we did to come up with the Docker containers and whatnot is just, oh man, I wish I knew
Yeah,
this. But now that we have this, I will leave this because maybe in the future this will no
it
longer
will
be true.
change. Yeah.
Oh,
If we can trust SHA-256, which
yeah.
I think I'm happy to do.
So yeah, we know how to check the checksum of a file. And I want to do a bit of a refactoring here because this is the part where we download the file, and this is the part where we check the name, we check the checksum, but this path is the same in both places. So I will do a quick extract variable refactoring here. That will be maybe the stub path.
Yeah.
And the stub path is equal to that. And then I have both copy and paste. This is better. So stub path. And we download the download path and we write to the stub path. That is very readable. I like this line.
Yeah, me too. It's cool.
And then we are saying that
I don't like having a weight as a parameter, to be honest, though. But
oh, you don't like this part?
Yeah, I don't know, like seeing a weight inside a parameter, just I don't know, just not used to it. This doesn't seem very conventional. But it totally makes sense. Like it's a very readable line. So
okay,
all good.
So the stub, what do we call it? The stub hash.
Yeah, that's a great name for it. All right.
So we run that, which is slower on Docker. It's faster to run natively. Fun. Oh, this is actually going to download the thing again. I did not comment out this line, so that's cool.
Yeah.
Every time we run this, we are actually downloading. And then we are using the checksum. We are producing the checksum, so we have here the checksum. And then you have this parse file function that will look at the file and the stub name.
Yeah, so we have to read that first.
And
find out the hash.
I have an idea.
Yeah?
What if we do it this way? After we have the stub hash and the stub, which I probably should rename, maybe call this the stub name. Now that we have both of this information, we can reconstruct one of these lines. So we could do this. We could just concatenate the stub hash with the stub name and check if the file contains a line that reads like this.
Yeah. We could do that. And that saves us having to use my function, which is good. Yeah,
So-
it would be simpler. It would just be like, just find in this file or include.
So
like,
I
group
will
is a string.
read file of checksums.txt, except that I have to do the same path join situation to get the right one. So I'll, quote and quote. So, okay. So now I have read the file. So this is the checksums. And of course I want to read the file in UTF-8.
Mm-hmm.
And
Does
then,
it have a hyphen or not?
sorry, no, that's optional.
Okay, yeah. Cool.
It should have auto-completed.
Yeah.
Well,
It's probably because you're in JavaScript. I don't know.
maybe. In any case, so now we can check the checksums includes a line that reads like stub hash space stub name, and then we'll make this into string interpolations.
Mm-hmm. Makes sense.
And I'll call this David because I don't know what to call it.
Might becoming your default variable name.
And I'll print David.
Nice. This is very readable. Much simpler than what I was going to propose.
It should print true, and it does.
That's really cool.
So we know how to check the checksum. The next part we have to work on is
Reading it first.
so we have to check if a file is already there and download it conditionally, and then we have to
Exactly.
figure out when we want to do this, whether when we are running or when we are installed. But I think that now is a good time for us to wrap this up. Do you want to
Okay.
join me tomorrow?
I will see because I have a few other things, but I've really enjoyed it and I would love to
Okay.
continue on it.
Okay,
So I'll keep you updated tomorrow, but that would be great if I could.
okay, so we'll see if you join us tomorrow or not, but I will be here at the same time, 5:30 UTC. I'll be here working on these next steps. And David, thank you very much for joining us. It is a lot of fun to have company and write some code together. Do you want to plug side projects, or maybe if you have Patreon and PayPal, this sort of thing, and maybe your company, maybe you're hiring?
I can't think of anything right now.
Okay.
That's okay, but I appreciate you giving me the space. Next time I'll prepare something to plug.
Okay. You can always, if you remember something, just email me and I will put it in the video description for people who watch on demand. So yeah, thanks a lot for joining me. Thank you, IDDQD Sound, for joining us on the chat. And thank you all who joined us and didn't say anything on the chat. I'm always happy to have you all here. And yeah, see you tomorrow for more work on caxa. And that's our show for today. Thanks. Bye.
Bye.